So, hi from me, I'm Maria. I'm a bioinformatics engineer and I work in the Center for Genomic Regulation in Barcelona. And I'm going to talk to you today about how to basically manage reproducibility and production of genomic workflows using Docker. So I don't know how familiar is the audience with like all this genomic data, but so if you ask like why biodata is like so special, the first answer is that they are very, very big. Actually, it's expected that big biodata is going to be the biggest of the big data. And then people normally ask, oh, why is that? Is the genome so big? And well, the genome is big, that's true. But the data that has to be stored for each genome is actually 30 times the size of the genome. And this is to make up for all the errors that occur during sequencing and preliminary analysis. And on top of that, it is expected by 2025 that we will be having between 100 million and 2 billion human genomes sequenced. The data storage demands for that is between 2 to 40 exabyte, meaning that storing and processing this genomic data will actually exceed the computing challenges of running both YouTube and Twitter together. So this is why big biodata are so interesting to people and why there is so much fuss lately about it. Now, what's more, they're very complex. And they also come with many different types because they depend a lot on the sequence technologies. And this results in like also different filtering and processing needs. And of course, they are ever changing. Like the moment technology changes or some filtering processes, all downstream analysis changes. So, for example, if today sequencing changes, we have a breakthrough technology out there, we'll need a second workshop, and whatever I'm going to be telling you today, that won't stand, more or less. So this is the world of big biodata. Now, in the real world, so genomic workflows that are designed to deal and analyze this big genomic data, they consist of like multiple stages, and each stage executes different scripts, system commands, and external tools that are being normally deployed in a hosting computing environment that normally it is an HPC, right? So because of that, of course, these data are complex. Maybe I can use this. Oops. This doesn't work, or well, doesn't matter. So they are very complex. They consist of multiple third-party software. They have, of course, many dependencies, and again, they frequently change because if you find a new type of analysis that it's better, or you need more information to be taken account in a specific pipeline, you need to change the pipeline, and they are always changing. And another thing I would like to highlight here is that also scientific software, now it should work, yes, also changes due to their like research nature based, right? And what is also very essential here is proper versioning, because even sometimes different releases of the same program can actually produce dramatically different results. So what I have been telling you for the past two slides is that the big data, not the big data, their workflows, and even the programs that the workflows call, everything can change from one day to other, and they will keep changing, and there is nothing no one can do about it. Now, on top of that, they are very big and very complex. And to make things work, someone needs to take into account all the dependencies and the demanding, the computational demand of all of these analyses. So I guess you can see the problem, right? That maintaining such a scientific production chain with controlled version within a standard production environment is almost impossible in practice. And to make the impossible possible, we created Nextflow. So before going on what it is Nextflow, I wanted to realize something. We are a group in my center of like 10 people. Half of us are like coming from a computational background, and we do a lot of sequences because we are part of big consortiums and a lot of NGS analysis, right? So most of our days we look like this, or we used to look like that 3 years ago, before Nextflow. like looking at our like cryptic bash scripts, trying to figure out, oh my God, why this is crashing again on this HPC cluster? What went wrong? What dependency? Oh, I need to change this. Where is the line number 500 something that I need to change this specific like configuration, right? And by the end of the day, we look like this. And then at some point we decided, okay, we cannot go on with our lives like that. And then one of the main things that we were wishing is that our cryptic bash scripts can actually handle data parallelization without us having to write a single line of code. And in our effort to actually make that happen, we stumbled upon the data flow model, which is a high-level parallelization model that allows automatic data parallelization, and Nextflow was created. Another thing that we had as a big problem is like, imagine having a huge genomic pipeline is supposed to run for 3 weeks. Week number 2 crashes, and then here you go. 2 weeks are lost, you need to restart, right? But you have deadlines, and you have your collaborators in America that they need to present the results in the NIH, that they need to get the next grant, right? So big problem. So what we developed in Nextflow is a caching system, basically, that allows for continuous checkpoints. And most importantly, it actually allows you to resume the pipeline from the last successful executed step. Another thing is that, so basically Nextflow, it's a framework, and I didn't say that, sorry. It's a framework, so it's a domain-specific language based on Groovy. And we were really, really enjoying like creating all this new language and all these new bioinformatic operators, and we're like, oh my God, we're so fascinated by that. But at the same time, we weren't ready to give up our favorite Perl scripts, Python script, Bash scripts, right? Not to mention that we really do have a special relationship with one-liners. So we turned Nextflow to polyglot, meaning that you can open what we call the 3-quote block, and you can write whatever you want there, as long as it's a scripting thing, and Nextflow can execute it, zero problem. Then we were really searching 2 years and a half ago, actually, for a way to package everything when we ship them, because as I told you, whatever we design in our laptop, it's meant to run on an HPC cluster, if not on a cloud or not in the Barcelona supercomputing center. So then we stumbled upon Docker. Docker back then was just a GitHub project. No one almost knew about it. And we contacted actually the people that were making Docker, and we're like, okay, how can we integrate it? And Nextflow was actually the first framework that was giving full support of Docker. And even up to date is the only scientific framework that provides that support. Of course, we made it portable with all the platforms, at least the most used one. And also Nextflow offers a good, has a good integration with GitHub, Bitbucket, and GitLab basically for sharing. Now, the Nextflow rationale is to reuse any existing scripts and tools. To do high-level parallelization, you don't write anything. Nextflow does it all for you. To be portable across platforms. And of course, when you combine all of this together, the ultimate goal is to enable reproducibility and to be able to like ship everything everywhere, and people use it like with the magic tagles like start, run it, done. So that was the concept. And how it works, okay, so you have a workflow which is like, it's written in a declarative manner. I don't know how many of you have done functional programming. So for those that have done functional programming, it's very easy to get the Nextflow concept. For the people that are used more to like scripting and like doing things in kind of like messy linear way, it's a bit more difficult to actually get the concept, but it's not impossible. So basically you have a pipeline that is composed by several processes. Each process has a set of input, output, and a script snippet to be executed. And now the question is like, okay, if I don't tell Nextflow like how to do the parallelization, how does it know how to parallelize my data? So basically, it gets the parallelization from the task dependencies, which are defined implicitly by basically the input and the output of the different steps. And this is how a process looks: input, output, and your script. As you see, this is Bash, and that's it. And if you here had like hello, hola, ciao, it will just run it automatically. Like it will call different nodes, for example, if it runs on a computer to print it. And this is exactly what I was saying before. So it creates kind of like a channel, and everything runs in parallel, your data basically. Yeah.
And is this, the output and input is a type, so that you say this script outputs FastQ or whatever format you have, so that you can only specify pipelines that work together? I mean, if you have different chunks and one outputs Excel files and the other expects CSV files, then you say like, have it like a type?
No, so we have, so Nextflow has different level of like Nextflow experts. Is the ones that they just don't care about Nextflow. All they want is get their bash script in, like, split it in tasks and just have it parallelize their data. And there you don't need to like specify anything, no FastQ, no nothing, input, output, and then things go like that. But then we have created Nextflow operators, as we call them, and there we have FastA, FastQ type. So then if you want to be specific and you want to be more fine-grained and you don't want basically to have everything in bash, although they are in task, yeah, you can do more fine-grained programming. And of course, there are like the Groovy experts, where they can use all the magic of Groovy and Java, and they can even exceed the Nextflow language, basically.
But wouldn't it be nice if you have, like you said, a 3 weeks running job, and the last step is putting CSV to Excel? Or
yeah.
And as it happens, the last step, or the step before the last step, exports something else. So, but you didn't anticipate because someone changed it just saying it's the last step, the functions of the step.
Yeah.
What it comes down to, like having. Like
no problem. You can change the last step. If the previous, like, let's say you have 7 steps, 7th step was changed, someone did something stupid there, and it doesn't work anymore, or it doesn't give you what you were expecting. No problem. If you have cached the other 6 and you are sure they are correct, you change the last one, you do -resume, and it will give you what you are expecting,
but
basically.
If you type input and output, then you can pre-check if this pipeline will even work.
Sure. Yeah, you can.
You're saying this step outputs CSVs, and the next step will input CSVs.
I agree.
You are certain that it will work?
I agree. You are completely right. Yeah, I know what you mean. But we are 6 people. That and Nextflow was not even a major project, really. Nextflow was like a side thing of like us going crazy. Okay, we're computer science. We have to do something. We cannot keep living our lives like this. So. It's a lot. I agree with you. It's a lot of like.
That's the best motivation. Is it open source though?
Yeah, everything is open. Yeah, and it has its own site, and we have documentation and everything. And we're more than happy for ideas and people to contribute if they want to. So basically, this is how it does. So it gets the input data. It does the splitting. It does the task, the map, and again, it collects everything. And I'm going a bit fast. So this is how a real script will look, right? This is a blast script. So input, output here. Here are the paths, basically, input, output, and the script. But here is just a blast call, basically. And the only thing that you do is Nextflow run, blast test, NF, and you can even do it like even right now. And this is what Nextflow will do, and it will keep doing that regardless if it is your laptop or you have moved it on the HPC or you have moved it on Amazon. It will keep doing the same, and it will understand on the one case that it has cores on a computer, in the other one that it has nodes, on the other one maybe that has pod instances, or blades if it's in a supercomputing center. Now, I want to focus on Nextflow with Docker and not so much on Nextflow. And the idea here is actually to empower reproducibility, as I said, and to be able to like run this, to share our pipelines and run it across different platforms, right? And so a pipeline is self-contained, and you have all your external scripts and configuration kept in a container, right? So I'm not going to go more into this. So here are the beautiful containers, right? It's a very simple context. Like you can put whatever you want. This you can have balloons, they're ducks, they're oranges, and it doesn't matter basically. All come in one nice package. So it has already been mentioned that the way to do it is like, let's get my script, let's get everything, and let's put everything into a container, right? Wrong. So if you do that, then you will kind of like kill data parallelization. It's not going to be that easy because everything is going to be confined in a Docker. Of course, unless you have 40 people or you have a company that really does good Docker, whatever, modifications to actually make it run really good. But if you don't have that, then what we do is like, put in the Docker only your binary tools, your environmental configuration, leave your Nextflow workflow outside it, and then basically, Nextflow, let's say you have a script that has 2 tasks, and if you had put it all in one Docker, it will run everything serially. Now that the tasks are independent, Nextflow actually can call one Docker, one container can initiate one container for task 1 and another one for task 2, and then run these tasks in parallel, and then collect the results in a table or whatever you want to do. And how it would look in a cluster would be like this. Nextflow basically will ask for nodes. On every node will like start containers with switch off container based on your workflow. So you kind of like understand this again automatically. All you need to know, all you need to write is to specify your images, and for each task, like each image, each container has to be executed. And this is how it will look on Amazon. So again, you have Nextflow, but this time you need a scheduler that will instantiate the spawned instances. Then Nextflow will start the Dockers on these post instances. So here I'm showing cluster K. Why cluster K? So I don't know how familiar are you with Amazon? Okay. So cluster K is a company. It was a new startup that was bought from Amazon like 5 months ago for 50 million euro, because it created this beautiful scheduler, Cyrus, and Cyrus is able to deal with spot instances. Basically, it's like a broker for stock market. And Amazon just bought it, and this is going to be offered as Amazon services in the future. So Nextflow is already, again, we had contacted them, and we had already like adapted Nextflow and everything, so it already runs. Now it's not possible anymore. Amazon closed everything. And now, let's have an RNA-seq pipeline. So, a real one. So normally here we are, what we have is read pairs. So basically, small chunks of DNA. Then a reference genome, we're trying to basically map this, and then we try to do transcript quantification. And I will try, so this is the Nextflow website, and it's really easy to have Nextflow up and running. All you need is the Java version 7+. Then you just copy paste this, and then that's it. You give it 1 minute to, and Nextflow is installed. And here, so here is just, maybe I can, oops. Oh, well, oops. Does this look better? Okay, so, oops, sorry for that. Okay, so as you see, this is just an empty file. I have nothing here, right? So, but I have Nextflow installed. And what I do, Nextflow run RNA toy, which is the pipeline I showed before. And Nextflow will try to run this thing. Let me see, yeah. And it breaks. Why does it break? Because this is my Mac. Of course I don't have all the pieces that a genomic pipeline requires installed here. So what I do, minus with Docker. And here we go. Mapping, building index, mapping, and hopefully, sorry, it's a Mac. It's a MacBook Air, so everything will go slow. So basically, I don't even actually have the RNA toy pipeline on my Mac. And here you can see the results, which are basically these files here, which are the transcript quantification, basically, if I do cut. Right. So, looks beautiful, right? That's why we were like, so here is where the RNA toy is. So this is on GitHub. I didn't have it online, but what Nextflow does, because it has GitHub integration, actually first scans your computer. So like, she asked me to run RNA toy. I cannot find anything called RNA toy. Then it goes to GitHub, and it's like, do you have something that's called RNA toy? Ah, found it. It clones it, right? And then it sees that, and when I say it with Docker, if I don't say with Docker, then it expects that I have installed everything that the pipeline requires to run. But I don't, and then it crashes. Then I say with Docker, then it realizes that in this GitHub repository, it should have a Docker image that has to pull down and run it. And if I do here, okay, Docker images, you can see it here, right? So that's the image that was required. So it gets also the image down. So here I did the trick. I had downloaded the image from before because it takes a bit more time to get the image for the first time, and then it runs faster. So go.
And expect the image name to be a Nextflow. Nextflow.
I will say. So I will skip this because this has to do with subversion. This is what I just showed with Docker, basically. And this is the support for different platforms. And this is what you asked me. So basically here, you need for each process to tell it. Like, the image you're going to use is this one. And then you can give whatever image you want. Here you can specify the executor. So this is how it knows. You don't need to specify much more because it knows. It has, as I said before, here, it has supports for all of these platforms. So as long as you just say, we have different names, SG, SLARM, whatever, and then you give, if you have a specialized queue or memory requirement. So this is basically the configuration file, and that's all the thing that you need. And of course, you need to create the image, right? So to finish with my presentation, now Nextflow and Docker, what it does, it actually allows you to have self-contained and reproducible analysis. It simplifies parallelization, and it's portable across multiple platforms. If you are interested more, I will give this talk on Wednesday, but if you are interested more about the impact of Docker containers, we published a paper, and that came out last week, that actually we measure the impact, like what's happening with genomic pipelines, and we provide our equivalent IBM statistics. And one last thing before closing. I don't know how familiar you are with CI, but basically these are like online platform that you can actually get your code and you can run it. So this, before Docker, was not able for like scripting stuff because you need to have all the dependencies and now on. But now that you have Docker, you can actually combine everything, and then you can just pull to these platforms, and we have this another one of the features that Nextflow now supports. And then basically here, whoever like does any kind of change, you can just run it on your browser on these big platforms that are open, and then check that everything is okay with your pipeline. So going back to we don't have what you asked, the alert, but at least you can check that whatever you are doing, it's working.
If I may be the devil's advocate, I mean, this sounds a lot like Storm, Spark, Flink, and all these streamlined process platforms that are from the other part of the IT world.
This one,
no,
or
I mean,
the other, the data flow.
Nextflow.
Yeah.
I mean,
it's similar to change the map reducers.
Yeah, kind of.
Yeah, it is.
Have you considered
Google
this as well, as integrating it to Flink or Spark, Storm, all these projects?
So Spark is a data flow based model. Google, a year and a half, last summer, so yeah, a year and a half more or less, they made a fancy statement and advertisement that data flow is the successor of MapReduce, that is going to revolutionize the world of big data, so on, so on, so on, so on. So yes, it comes from the other side, but as I told you, our motivation was that we wanted something that handles parallelization for us. And I'm sorry, but I'm not going to write CUDA. I'm not going to write even Bash. I'm not going to go write MapReduce. As long as I can have something, I have task 1, task 2. This is input, this is output. The output of this thing has to go to has to be the input of task 2. I expect my framework to understand it. In our hands, it does miracles. It solves our problems, and this is the only reason why we created it. Now, it has been useful for many other people. We are already working with Sanger, Broad, Max Planck. We have several different other institutions, companies. Cornell made even, they created an IDE that, so basically, whoever works with editors, there is a Nextflow support thing that kind of you can edit stuff. They use it and so on. So this is us. We're 6 people literally, and Paulo is the beating heart of Nextflow, and he's the lead. So me and Pablo are already here, so you have half of the team here. And we have Nextflow repository. We have the homepage, and we also have a 24-hour communication port that whoever can ask us. And Paulo is really amazing in answering on 24 hours. So yeah, and that's it.
I'm Pablo, not Pablo.
That's Pablo.
Very important.
Yeah, and that's it.